Welcome back. This is the second half of Lecture 1 for the first week of school. The next tool that I wanted to introduce that I was cut short on was the buffering tool. Now the buffering tool is really exciting because it allows us to make these distant buffers around a point, around lines, around polygons. So this map we're seeing here is showing point data where we have done a buffer of 2 miles or 2,000 feet radius around these points. And it shows us, it highlights all of the neighborhoods that need to be identified in proper ways to dispose water because they live in a sensitive vernal pool area. So buffering is another tool that allows to help with the whole spatial analysis. We can see that we have a north arrow, scale bar, and a legend for our final map here. Now remember that all of these tools, these are all separate tools, but collectively they make up GIS, Geographic Information Systems. So they're very important. And keep in mind that if you don't recognize any of these tools or any of these words that I'm saying, then you're in the right place because we're going to be learning about these all semester. So now let's talk about a map. In class we're going to be doing some mental maps, drawing some mental maps. But I want to show you a comic that is highlighted in your textbook. And this comic is looking at how the little boy can find his way home. And he can spatially remember how to get home if you go back to the school. If you first go back to the school, then he can retrack the route, how to get home. But take him out of the school and put him in a different location, it's hard to route back. So that's very important. This is called a mental map. And so we'll be talking about mental maps later. So let's talk about the components that give maps its mappiness quality. So we talk about many cartographic maps that have certain characteristics. And we're going to talk about 6 of these characteristics that give a map its mappiness. And the first characteristic is our vertical or oblique views of an environment. So let's look at some examples here. So vertical or oblique view. Now the map on the left is a vertical view, meaning that it's a bird's eye view looking down on the topography, looking down on an area. The map on the right is an oblique view. Now, so this is very similar to looking at it from the side. So notice the difference between the oblique view and the vertical view. Here are 2 more examples. I'm looking at Mount Hood up in Oregon, a view from above and a view from the side. So again, comparing vertical versus oblique view. Now notice these 2 images, they're kind of artistically, cartographically rendered to make it look as real as possible. Now I ask you, here's an example of a map that depicts the migration out west of a caravan of folks. So is this an oblique view or is this a vertical view? Now, because we're not looking straight up and down, it's most likely an oblique view. And notice how we get that kind of terrain effect. Another component that gives a map its mappiness is that maps are created at a reduced scale. And we know this because if they were created at a one-to-one relationship, the map would be reality, the reality in which we live in. We know maps are projected, as we talked about the different projection type of tools. And maps can be projected in many different forms. They can be a conic projection, cylindrical projection, plane projection, or can be interrupted projection. And all these projections give different types of map properties. And we'll talk about this at great length. We know that maps are highly generalized, that maps cannot have the same amount of detail that we see on a day-to-day basis. So these generalized maps, for example, the map on the left is a upper atmospheric dynamics map that's looking at the jet stream and wind speed. And the map on the right is taking that information from the left and highly generalizing it. So notice that it's much cleaner. A more general audience can use this map. And so that's what I mean by generalized maps. We know that maps have symbols and colors and patterns and different text and different lines, and they have a different texture. And all of these components give a map its map-like qualities. So this is a beautiful map made by Tom Patterson, who's the lead cartographer for the National Park Service. Now notice that we have the use of some beautiful fill, outline colors. Notice the nice names of the creeks and rivers, how they're blue and italicized. Now they're that way for a reason. All rivers and lakes need to have a blue color associated with the label. And the last thing is that a map needs a purpose. If someone's trying to make a map with no purpose, there's really no point. So it has to have a purpose. What's the purpose that this map is fulfilling? So here's an example of this particular map from your textbook. What do you think the purpose of this particular map is? So let's first identify all of the elements that we see on here. Now the first thing that my eye sees is that this inner circle bullseye graphic, where there's a red dot in the middle and larger circles radiating out. That's the first thing I see because it's red. The second thing I see are the roads. So we see a somewhat of a hierarchy of the information that we're looking at here. The third thing I see is the counties, which is the gray lines. And then the last thing I see are the white river labels or names, and then the white rivers themselves. So if you had to guess the purpose of this map, one could say maybe perhaps it's driving distance from Bend, Oregon, just because the roads are so prominent in relationship to the circles. That would be my guess. But what do you guys think? Could you come up with a different purpose? We can talk about this in class. So here's another example of the use of maps and graphs and images to help tell a story. So this was a map that was in the Washington Post Sunday edition that a friend of mine made. And this was a map that would tell the story of how illegal timber travels from Burma through China. Now notice the elements, the telling the story of how the timber is logged, looking at the statistics, so looking at the bar charts of percent of country log exports that went to China and the estimated percent of total productions that's illegal. Now we go down to the second image in the lower right hand corner and we start seeing a location map. So a location map of where we're talking about. We also get a little bit more information. We see a flow map. So we see that the arrows at the bottom of your screen is showing the direction in which the illegal forest products are traveling. So again, another important map element that allows for the purpose of the map to be known. And then as we move on, we get to use some aerial images from two different periods of time, 2001 to 2005, to help paint the picture of what are we actually referring to when we're talking about illegal logging. So if we look at all these components together, we see the use of bars, maps, larger maps, and aerial imagery to really all come together and support the purpose of this article, which was to describe the travel of illegal timber from Burma to China. So a very powerful component. So let's go ahead and talk about map elements. So when we talk about map elements, we're talking about the base data elements. Now I've made a handout available on Moodle, so you can see what I'm talking about with these elements, but we're going to go through them briefly here. So when we talk about base data elements, we're talking about external base data, and everything that is referred to as external base data, these are things that the map maker has control over. So for example, the title and subtitles. Okay, this is something that's up to you. You're the map maker, you are the collector of the data, you have the flexibility to make a title. These are the captions, these are the legends, these are the scales. This is the source, the credit, and the logo. The north arrow, you can choose to put it in the lower right-hand corner, upper left-hand corner. You can choose the different styles of north arrow. You can choose the coordinate system or graticule that you would like to show on your map. You can choose outside border or a neat line around your map. You may want to have a smaller inset map that shows you the general location of the map. Or you may want additional notes to help the map reader understand what you're talking about. So let's look at some of the examples. So typically, and this is what I want you to be practicing throughout the semester, is when you make a map, Keep in mind that the title, you want to include what, where, and when, only as needed. So population density of California would be a great title, and then have the year. You may want to use a subtitle if you feel that there's more information needed. Examples of a caption. So if you feel like there's any additional information that needs to be known about the map itself, you could use a caption. Examples of captions would be figure titles, where you give a little bit of additional information. We see two different types of legends here. The legend on the left is looking at roads, so looking at different line characters. The legend on the right is looking at a standard deviation, going from the no change to gain up in the upper part of the legend to purple, or to loss, which is down at the bottom, which is the orange. We can see that the legend for a simple transportation map consists of street symbols or road symbols, different line colors and line textures, and different point symbols. We can also see, based on this type of map, we have different types of symbols here, such as news symbols or stadiums, craters, geysers, churches. So this could be possibly a location map, amusement parks. So two different legends. So depending on the purpose of the map, that's gonna really drive what type of information you have on your legend. Some more examples of different types of legends. We can see the use of different colored lines to symbolize different things, such as a transportation corridor, forestry area, shrub area, grassland, urban areas, water, and so on and so forth. The bottom legend is representing a planning map, looking at the rural land use zoning, so we can see how polygon or circles or squares can be colored of different values. And then we can move on to some more physical geography focused legends. So we're looking at contour lines on a topo map. We're looking at state lines. We're looking at different lakes. Adding more physical components such as swamp, glacier, sand into the mix of things, and we have a different looking legend. So legends are very different based on the data that you're working with and the purpose of your map. Additional notes, you may want to add that this project was founded by someone in particular or a foundation in particular, or that you may want to thank your favorite teacher for helping you create this map. So whatever you feel like is important. So again, all of these examples are external data. These are things that you have the power to control. Now let's talk about internal base data. Now, if you could control external base data, internal base data are things that you cannot control. And these are things such as physical and cultural features. These consist of landmarks, regional boundaries, administrative units, transportation networks, hydrology systems, or hydrography, or topography. So things such as landmarks, you can't change the name of the Statue of Liberty. You can't change the county name of Shasta County or Siskiyou County. These are physical or cultural features that stay consistent. And then with those features comes their symbology and text. Those don't change. The name's not going to change, and so on and so forth. So sharing your maps with others, what type of information would you want to include? Okay, so when you are doing a map project or doing a lab activity and you have the capabilities of including a lot of data or little data, you need to ask yourself what type of information you would include. Well, this depends. This depends on the type of map that you're creating. So that's going to always influence what your map looks like. So let's look at some examples of maps. So the map that we see here on the right, what are some of the major features that we see? Now, just looking at the map, I see Canada and the United States. The labels are very large. We see the Rocky Mountains. This would be a general purpose map. Another type of general purpose map, we see the physical map of Australia, or locating physical features. We see a thematic map, looking at the different types of management agencies. We see a series of maps that are looking at different features. We also see a generic names of soft drink map, which we identified earlier as a chloropleth map. So we are going to pick up this map discussion in class on Tuesday in lab I look forward to seeing everyone then, and hopefully you view these 2 videos prior to showing up to class.